Hey everyone, it's Justin, and in this video we're going to be discussing the 2008 AP Calculus AB FRQ problem number 4. We have done this problem before in class, but today I'm going to go a little more in depth on it. For this specific problem, what we have to do is we have to analyze this velocity versus time graph. Alright, so before we really go into the problem, what we got to do first is start kind of labeling and writing down the information we're given about the graph. So what I've done is I've made a larger version of the graph here, as you can see. And what I'm going to do is I'm going to start labeling the different points of intersection by drawing X's. So that's point of intersections, sorry, not intersections, but these are the x-intercepts, so 0, 3, and 5. The area here, we're given that it's 8. We are told that this area is 3. I'm just going to kind of extend this line down here, and this is going to be an area of 2. So we're given those, so then at 1, we know that there's a tangent line here, so tangent line where the slope is 0, and that goes the same at t equals 4. So we would write the same thing. So tangent line with slope equals 0. And m is the same thing as slope. So that's why I'm using that. In addition, we know that the initial position of the particle is at -2. So given that, this is all the information we need to know for the problem. So in part A, the question asks us to find when the particle is the farthest to the left, or basically when the particle has the largest negative value. And it also asks us to justify our answer. Since we are given the areas, which are 8, 3, and 2, we can add these values together along with the initial position of the particle, which is -2. And by adding these together, we can find where the particle is at different times. So since this area is below the x-axis, this is technically a negative, and that's also negative, just reference-wise. So using this information, what we can do is we can say that the initial position is equivalent to -2. So if we end up adding the areas of the different regions, and these areas, since it is the area of the velocity versus time graph, what will end up happening is that these areas are actually equivalent to the position. So if we add, so this is -2, so this is at 0. So if we add the areas when time is between 0 and 3, time is between 3 and 5, and when the time is between 5 and 6, what we'll end up getting is it's -8 minus 2, so that's -10. This becomes -10 because we take it from over here. We do -10 plus 3, so that's -7. Then -7 minus 2 is -9. So looking at these values here, we can obviously see that the largest negative value is -10, which is from the region of 0 to 3. So that means that the time when the particle is the farthest to the left is when time is equivalent to 3. So that's our answer. For part B, we are asked for how many values of t where 0 is less than or equal to t, which is less than or equal to 6, is the particle at x equals -8. Explain your reasoning. So in the graph, what we can see is that originally the particle is at x equals -2. In addition, we are given that the areas are -8, 3, and -2 for the different regions. By adding the initial x value and the areas together, we got the positions of the particles, just like we did in part A. So by doing this, what we'll end up getting is the values we had seen in the past. So at 0, the position is at -2. Between 0 and 3, the particle is at -10. Between 3 and 5, the particle is at -7. And then for between 5 and 6, the particle is at -9. So since these are the different positions, that means the particle ends up traveling, say, down here, this is like -2. That means as it travels, it goes to -10. Let's say this is -2. Let's say this is -10. So it actually starts here, it goes down to here. Let's say it's -7 about here-ish. And then it drops down to -9. Okay, so if this is where -8 is, if we look at this kind of sketch we made, that means it hits it once, twice, 3 times. So that means it was at x equals -8 3 times. So for part C, what the problem's asking for is it wants us to find on this interval where t is between 2 and 3, it wants us to find whether the speed of the particle is increasing or decreasing, and it wants us to give a reason for our answer. So in order to find if the speed is increasing or decreasing, that means that the sign of the velocity, so velocity's sign, that means it must be equal to the acceleration sign for it to be increasing. All right, so leads equals increasing. However, vice versa is if, let's say, velocity, instead of writing velocity, I'm just going to write v. So v's sign is not equal acceleration sign, and acceleration I'm just going to write as a. So if they do not equal each other, that means that the speed is decreasing. In order to look at their signs, we got to see, well, we have to refer to the velocity versus time graph. So our interval here is going to be between 2 and 3. Okay. So what we have for this is between 2 and 3, we can obviously see that the velocity itself, so v is a negative, but then we can see that the slope, which is the acceleration sign, so we can see that the acceleration sign is positive. So since velocity's sign, since v is negative and a is positive, that means the speed is decreasing. Finally, we have part D. Part D asks about the acceleration or the slope of the velocity graph. Using the same test from part C, we can go and look for when the slope of the graph is negative. Looking at it, we can tell that it is negative from 0 to a 1, because the slope here is 0 since there's a tangent line. That's 0 here. So that means from 0 to 1, that's a negative slope, and then from 4 to 6, it's a negative slope. So what we can say is that acceleration is negative at 0 and 1 and 4 to 6 because the graph slope is negative there. In summary, the problem was really easy since it was really conceptual. You didn't have to use any complicated math. However, you did have to pay attention to the axes. So a trick for that is you just circle the axes on the graph. And another trick is to write the givens from the problem onto the graph so you don't forget about it. Thank you everyone for watching. See you next time.